Hey guys, we're back. Okay, the last set of problems that we did was mole to mole stoichiometry, with where we were given moles and our answer was moles. Okay, so the next kind of problem we're going to do is mole to mass. So we're going to be given a number of moles of one of our items in the balanced equation and be asked for the mass of something else in the balanced equation. But because everything relates to everything else in the equation, then we will be able to do this without any problems. Now, we're going to need a balanced equation. We're going to need our periodic table, and we're going to go to page 376 in our textbook and look at practice problem number 13. So let's read this together. This says sodium chloride is decomposed into the elements sodium and chlorine by means of electrical charge. So just energy is being added. How much chlorine gas in grams is obtained from this process? And it shows you a little diagram over there of what's happening. So if sodium chloride is being decomposed, we know sodium chloride is NaCl, right? And this is decomposing. And it told us, and we can see in the graphic, that it decomposes into sodium and into chlorine. And we know that we have to, chlorine as an element is Cl2 because it is a diatomic. It's a Honkelbrief. And we also know that sodium is a gas. And we know that, chlorine is a gas. Sodium is a solid. And we know that sodium chloride is a solid. So we can go ahead and add those elements, that part, into our equation. Now this is not balanced, so every stoichiometry problem has to start with a balanced equation. So that is a must. So we have to balance this. So we have two chlorines here. So we need two chlorines here, and then we need to do a 2 here. So 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. So check on our BE. We've got our balanced equation. So we are ready to move forward with solving. So let's look at what we've been given. It says that we have 2.50 moles of sodium chloride. We're adding energy to it, and the question is, how many grams of chlorine come out of that? So now we can see this is not just a mole to mole problem, this is mole to gram problem. So we're going to start our work with 2.50 moles of NaCl because that is what the problem told us, the data told us that we have. Now we're going to write the mole ratio from the balanced equation. The balanced equation says that 2 moles of NaCl are in relationship to 1 mole of Cl2. In other words, if I were using 2 moles of NaCl, I would get 1 mole. But I'm not using 2 moles, I'm using 1.5 moles. And that there my question doesn't stop, right? I want to go on because mole cancels, right? If we did that work, we would get our number of moles of chlorine, but that's not the final answer that we want. We want grams. So now we're going to go back to our little infinity sign that we were doing in the last chapter, which is what is the mass of 1 mole of chlorine? 1 mole of chlorine. So now I'm going to need my periodic table. So I'm just going to write a little sidebar over here. So if I look it up on the periodic table, chlorine has a mass of 35.453 grams per mole, and it's Cl2. So I'm going to multiply that by 2. So Cl2 has a molar mass of 70.906 grams per mole. Remember, that's what we did all in our last chapter. So that's just a piece of information that I need to go up here. 70.906 grams in 1 mole. This is the molar mass. This is the mole ratio. So starting information, mole ratio, molar mass. Now mole goes away. And this is going to be grams. I wrote too big. Grams of Cl2. So now I'm ready to put my pencil down, like we talk about, my Sharpie, and pick up my calculator. So 2.5 divided by 2 times 70.906 equals, and the answer is, what my calculator is showing me is 88.6325 grams of Cl2, but that's too specific. I only have 3 sig figs in my original piece of data, so I can only have 3 sig figs here. So I'm going to look 1, 2, 3. Does this number make this round up? It does not. So 88.6 grams of Cl2. Now, that's the final answer. So let's go back and say, okay, so that's a number. Great. What does that mean? That means this balanced equation tells me what happens, how the ratios have to occur. My experiment was running with 2.5 moles. So when I run this experiment with 2.5 moles, I will get 88.6 grams of chlorine gas produced out of this. So that is the final answer to the question. All right, so let me show you another question, and I'm going to encourage you to stop the video and see if you can write a balanced equation for it. And so if you can do that now. What mass of hydrogen is produced when a 0.200 mole sample of sodium reacts with excess water to produce hydrogen and sodium hydroxide? So right now, pause the video and see if you can write that balanced equation being given the reactants and the products that we have there. Okay, so I wrote the balanced equation to be sodium reacts with water to produce hydrogen and sodium hydroxide. And then I'm going to notice that's just my skeleton equation. And then I'm going to balance it. So I'm going to look and see, I've got 2 hydrogens here, 2 hydrogens. Oh, that's all good. Are we ready to go? Oh, no, I have another hydrogen here, so that doesn't work, does it? So we're going to need additional hydrogen. So let's go ahead and balance it this way. With a 2 here, 2, 2. So 2 sodiums, 2 sodiums. And of course, remember the helpful tip that if you write water as HOH, then you can see, right? Oh, you can't see that, HOH. That sometimes it's easier to see how to balance that, okay? So there's our balanced equation. Now, let's answer the question. And I'm going to also ask you to pause and see if you can do it on your own, and then we will continue together. So a 0.200 mole sample reacts with water, excess water, so I'm not going to run out of water, to produce hydrogen and sodium hydroxide. And it says what mass? So what mass of hydrogen means question mark gram of hydrogen. Question mark gram of hydrogen. So 0.200 mole Na. Here's where we change the conversation with this mole ratio. The balanced equation says 2 moles of Na. Notice I always try to write my denominator first because I want these words to cancel. And then 1 mole of H2. And this is multiplication, right? And then, but mole is not how I want my final answer. I want it in grams. Well, how do we go from moles to grams? We use the molar mass. 1 mole of H2 has a mass of, and we typically for hydrogen just say 2 grams. Okay, you can do that for hydrogen here. each hydrogen being 1. So we're going to pick up our calculator. 0.2 divided by 2 times 2 equals 0.2. If you had a 1 here, with the numbers that we have, that's what we're going to get right there. If you used a different molar mass, you'll have a little different answer. We need 3 sig figs. I'm just going to go ahead and do that. Grams hydrogen. When 2 moles react, we get 1 mole of hydrogen. So that would be 2 grams. But we don't have 2 moles reacting. We only have 2/10 of a mole reacting. So my number of grams is going to be less. That should make sense to us. That is the answer to the question. Hopefully this setup, going from moles, so this is our mole ratio, and this is molar mass, right? Mole ratio, molar mass. Once we have a balanced equation, and that's how we're going to solve these problems, and hopefully you can do the next 2 that I'm going to ask you to look at.